Hello everybody, welcome to the Exam 1 review. So the idea behind this is if you want like a guided tour throughout some of the problems, you don't want to work them out and look at the solution, or you just want somebody to work them along with you, then that's what these are for. So when I do these, I'm going to always assume that you have the PDF shown, so I'm not going to rewrite the problem. I'm just going to assume that you're looking at it, and we're just going to work through each of these problems one by one. So let's go ahead and get started with number 1. It says use the table of values to estimate the following limits. So remember, that idea is you want to pick numbers that are really close to the number you're interested in, but not quite what it actually is. Now we have the machinery to figure out this limit exactly, but this is still a good technique to have in the back of your mind because not every function is going to be nice enough to do that. Or sometimes you're just going to have to take data points and see what happens as you get really close. So here, it's asking us to take this, the limit as x goes to 3 of x minus 3 over x squared minus 9. And the first thing to note, even if we were trying to just plug in, that wouldn't quite work. We'd have to be a little bit more clever, because if we tried to plug in, we would get 0 over 0 form. But I do want to keep that stressed, is that whenever you see a limit, the first thing you should try to do is plug in. But here that doesn't apply because we were told to estimate it and not calculate it. So what do we do when we estimate it? We pick numbers that are really close to 3. So I always do this, 2.9, 2.99, 2.999, and then similarly on the other side. So I'm adding 0.1, 0.01, 0.001, really getting in close. And the reason we look at the numbers on the outside is to make sure that we really are converging to some number, that we really are getting close. Because like if 2.9 is a number and then 2.99 is a completely different number and then 2.999 is even more completely different, then that tells us that maybe we need to look in a little closer. Maybe in fact our estimates didn't work. But here we go ahead and put these values in. This is what we're going to plug in. And then on my calculator, I'm going to go ahead and type this equation or this function into y equals x minus 3 over x squared minus 9. And I'm just going to copy right off of that. 999, 3.001, 3.01, 3.1. So let's see. I get here 0.16. I'm going to round to 3 decimal places to make sure at the end when I round I didn't mess something up. 0.167, 0.167, more 0.167s, and then 3.1 is 0.164. So, yep, that really looks like it's closing in on the value. And remember that the instructions say to estimate or leave answers as 2 decimal places. So we get limit as x goes to 3 of this function, x minus 3 over x squared minus 9, is approximately equal to 0.167. So that's our answer for this particular problem because it told us to estimate. If we went back and actually did the problem, calculated it exactly, we would get an estimate, or we would get an exact answer of 1/6. So that does turn out to be right. For part B, it's asking us to do the same thing, but for limit x goes to 0 of sine of x over x. So let's see. Same idea. Break out a little grid like this. So let me finish drawing my table. So I get what? If I'm putting them in order, 0, 1, plus or minus 1 1,000th, plus or minus 1 100th, plus or minus 1/10th. That's all that's going on here. 0.01, 0.1. And now again, plugging it into the calculator. This one we have a trig function, so absolutely make sure that your calculator is in degree mode or else you're in danger of getting it wrong. So just note that. Or is in, did I say degree? Radian mode. It needs to be in radian mode. Okay, so let's go ahead and start plugging in. Minus 0.1 is 0.99838. Same thing with 0.1. I'm just filling this out because I put it weird in my calculator. And then after that we have 0.99, and here we have 1, here we have 1, here we have 0.99. So then we estimate this limit, sine of x over x, to be approximately equal to 1. That's our guess. And as you should remember from class, that is in fact the right limit. This limit does in fact work. So let me just make sure I said it right. Make sure your calculator is in radian mode. If it's not in radian mode, you're liable to get a wrong answer, because everything we do in this class is in radian mode. But that's number one. That's using tables of values. So hopefully that works out nicely.